So the next set of videos will be on functions, and in Java we had methods, in C++ we have functions. That's basically it. Of course there are some minor differences and some, they're minor but they're pretty important. Alright, so for this chapter our objectives are to look at predefined functions. That is, in Java you might have used math.square root. Those kinds of things exist in C++ too. So we'll look at some functions that return a value. For example, square root does return a value, and there are some things that don't. For example, in Java we had system.out.println. Well, we don't have that exactly in C++, but we have something similar. We have a printf function, for example. We will then set up our own functions, and so these are called programmer defined functions. So we look at how to define them, how to declare them, and how to call our own functions. Take a quick look at recursive functions, but recursion is something that we will look at in more detail later. And we'll end with some scope rules. These are the same kinds of rules as in Java, except there's one difference, which is that there is a global scope in C++, which does not exist in Java. So in C++ we can have global variables and in this global scope. Nested scopes and blocks work pretty much the same as in Java, so no real difference. You may not have used nested scopes by themselves. You probably have used if statements inside, for example, another if statement, or if statements inside a while loop. Well, those are actually nested scopes, but we just never talked about those things as nested scopes. And the same kinds of rules actually apply in Java as in C++, with the one difference being that C++ has global scope. So there is a scope that's global. Okay. Alright, so functions, what are they? They are the building blocks of programs. We almost always in Java we need classes and methods. We could potentially write everything in one big public static void main, but that is a very bad idea. It's possible, but it's not a good thing to do. So almost always all our programs are built of smaller pieces of code which we put into methods. Same idea in C++, except we call them functions. So there are all kinds of other terminology in other languages. Procedures, that's what Pascal used, and Algol before it. Subprograms is the term that was used, I believe, in BASIC, and maybe some other languages too. And methods are what we used in Java. In C++ we call them functions. I'd still refer to these things as methods sometimes. It's basically the same idea. So there is this idea of the input, process, and output. So if you need to do this kind of work, if you need a box where you input certain variables, process them, and then produce some output, that's basically what functions do. It's a box, supposed to be used as a box, black box where you put in inputs, it does something, produces some output. That's the basic subpart to any program. So we use functions for these pieces or boxes where we get some input, process them, produce output. There's tons of predefined functions. There's a lot of them. There's no way we can list them all. There's just too much, and people write their own. We can write our own. I don't think we'll get around to doing that this semester, but it's possible. So there's libraries full of functions for our use. There's tons of them. You can download them. There's two types of functions, those that return a value and those that do not. The ones that do not return anything are void functions, like public static void main in Java. Same idea. To use a library, you have to pound-include them. So that's the preprocessor directive that we put at the top of our code, and then we pound-include the appropriate library. For example, math or standard lib, the original C libraries. IOStream we've used already for cin and cout. So there are a ton of math functions, and we get that by pound including cmath.h. Most of them return some value. For example, square root is one that we tend to use more than others probably. And so what are the components of this? There's a name, square root, it's the name of the library function. You return some value, you store it in some variable. So root just happens to be the variable that we are using to store the result of the square root call. And then the input in this case is a 9.0, a double precision number. This is called the argument, or the input for the function. So in this IPO, or input process output model, I is 9.0. Processing, what do we do with that? We compute the square root somehow, and the output O is 3. So this expression, square root of 9.0, is known as a function call. So this is how we call a function. We just have the name of it, and in parentheses we put in whatever arguments it needs. Okay, so you've seen this in Java, so I don't want to spend too much time on how basic methods work. So the arguments in a function can be, as in Java, a literal constant as we have here, or a variable, or an expression. So you can have something like 10 divided by 5, for example, if you want. Or you can have x times y divided by z. And it's by the call itself can be part of a bigger expression that you can then evaluate and store into a variable. So the basic rule is a function call is allowed wherever it is legal to use an expression of the function's return type. So as long as the return type is allowed in some expression, you can use it. So what it means is you can't say square root double ampersand for and something else, because square root probably returns a double precision value. You cannot AND it with something. So basic idea, same as in Java. Okay, so there's an example in the book where we use square root. I'm not going to go over it just because I think this is pretty straightforward. What is the key to getting it to work? It's just that you need this pound include cmath. You do that, and then you can call the square root function. So pretty straightforward. I'm guessing all of you can handle that. There's a ton more library functions that we can look at. Abs for absolute value of an integer. So if you put in a negative value as input, you get a positive value. If you put in positive, you still get positive. If you have a long int as input, you can use labs for long abs. If you want to use floating point numbers, you can use fabs. And so that returns the value of float. That star should not be there, I think. I don't know. We could try it out. Let's just take a quick example of this. So let's say pound include cmath should be enough. And let's try it. Float x is equal to minus 9.45. Let's say a nice number like that, and we say float y is equal to fabs x, and we'll use a cout and say x is x, oops, and y is y, end line, and Alright, we do get an error. Let's see what the error is. fabs cannot be resolved. So I think we need, oops, I saved it. And I think we're okay. Let's try to compile it. That'll be the test. And everything worked. No. Sorry, didn't compile it. There it is. Everything worked. Alright, we're done. Let's try to run this. Run as local C++ application, and there, sure enough, it worked. X is minus 9.45 and Y is 9.45. So you can try it with other inputs, but my guess is it's all working. So I don't know how that asterisk got in here. I forgot about that. So just ignore that. So fabs is actually in the library CMath. And so, yeah. All right. So I think that all works. You can also use the power function, pow x comma y returns x to the power y, just like in Java. Java we have math.pow x comma y. I'm not gonna spend a lot of time on the types expected because there are some differences in that. As with any other situation where automatic type conversion works, you can actually say int result equals POW, even though POW returns a double precision number. Remember, C++ has automatic type conversion, and so it can put the result of a POW call, a call to the power function, into an int. Java, you could not do that. Those of you who might have tried to use math.pow in Java, that returns a double. If you try to squeeze that into an int, you need to do some typecasting. By default, it doesn't work. Okay, so try this out. I don't think you'll run into any problems. So one thing to note that's different is that it has 2 arguments. And you can set up a function to have any number of arguments of different data types. And you guys have done that, I'm guessing. Here's another listing. Square root, power function, abs, long abs, and fabs. You can try out all of these. So the one thing to note, I guess that's what we were looking at a few slides ago. Abs and LABS, long abs, are in CSTD_lib, C standard lib, but fabs is in CMath, which is what we used. So if you need to use absolute value, you have to pound include C standard library. There's a bunch of other things. Ceiling rounds up always, so 3.2 becomes 4 as output, and 3.9 also becomes 4. You take the floor, which is sort of the truncating, removing the decimal point, removing everything after the decimal point, so that's different from ceiling in that both 3.2 or 3.9 as input to floor will give you 3. There's the exit function, which is just like the system.exit in Java. There's a random number generator, you can use that, and a seeded random number generator. Sorry, this is the set seed for rand. So srand is the set seed, sorry, that. And so you can set the seed and then call random number generator. Okay, so predefined void functions. Let's take a look at that in the next video.